Bismillahirrahmanirrahim. Assalamu alaikum viewers. Today date is 15th of December 2019. I am covering the difference between software engineering and software re-engineering. That is my today's topic of the video. Software engineering is the process when we develop a software for the first time, and software re-engineering when we redevelop a software. So for example, we develop a software from scratch base. As we talk about NetSol company developed a software for BMW for the leasing purpose, and that was developed from scratch, line one. So it will be called software engineering. So methodologies, techniques and tools were applied. Whereas when we redevelop a software, for example, we have legacy system, the old systems developed 15 years, 20 years before. And then we perform re-engineering to redevelop our software. The existing software is there and we redevelop it. For example, Microsoft Office was also gone through this process, and it is called business process re-engineering also, because Microsoft changed the business processes, and Office 2007 onwards we have new version, whereas previous Office was different. Software engineering has three types. We have reverse engineering, we have forward engineering, and we have restructuring. Reverse engineering, we have a software that was developed like 15-20 years before, and we lost the documentation, and we took the code, and the code we perform the design, we generate design from it. So reverse cycle, like in the car we have a reverse gear. Similarly, when we reverse the software engineering process from the code implementation to design, and from design we will generate the requirements. We have some re-engineering tools available, like Rational Rose is there, Star UML is there. So we load the code into re-engineering tool, or we can do it manually, that we generate design. And for example, from that modeling we have model, and then we perform the analysis to generate the requirements, and then we do planning. So it's a reverse cycle, implementation to design, design to analysis, analysis to planning. And then after doing this, we will do forward engineering, like the forward gear of the car. We'll do plan, replan, and we'll do analysis, and then we'll do design, and then we'll do implementation. I surveyed almost 100 software companies during my PhD. I found one company in my locality that is Lahore-based, Pakistan-based company, and they have one office in Pakistan, Lahore, and they have one office in America. So they were doing, its name is Technosoft. So they were re-engineering hospital management systems. So software, the systems that were developed in Java or in COBOL or in any other tool, they were doing re-engineering in .NET. So that is the reverse engineering. First they apply to take code, and then design, and then analysis, and then planning. And from planning to analysis, and then design, and then implementation in .NET. So that's the forward engineering. And then you have restructuring. Restructuring means reorganization of the software. We have two types of reorganization or restructuring. We have code restructuring, and we have document or data restructuring. Code restructuring, for example, in the maintenance projects, customer is sitting online, like in America, customer is online, and the Pakistani branch, Pakistani company, the local, they were doing runtime changes in the software, because now they don't have time to follow the template of the company, follow the coding standards. So they just want to fix the customers' requirements. If they keep on doing this process for a couple of months, after that the new code, the changed code is mess up. So there is a guy will sit after 1 month, 2 months to restructure, reorganize the code as per the previous template of the code and implement the coding standards. Coding standards help us, like indentation in the code, help us to do update or upgrade in the system. Because programmers are continuously switching from one company to another company. So the new guy, when he will come, he can read and understand the code and change the code. So that's the code restructuring. Similarly, when you are changing the code runtime, you don't do the documentation. When you don't do the documentation, mean your changed code has old documentation. So you did not perform the proper modeling or change in the architecture or change in the design. So your functional specification, your technical specification, design specification is outdated. So after 2 months or 1 month or 2 months or 3 months, documentation guy will sit and reorganize the documentation to make it compatible as per the new code. So the coding and the documentation should be at the same level, should be at the same format, and they are compatible to each other. So this is called document restructuring. Now we have few topics. For example, I'm going to discuss the attributes of a software. Software has many attributes, but few of them which are common and most commonly used. For example, we always need hardware to implement software. So hardware is one of the main attribute of software. Hardware could be computer, server, or mobile device, or embedded software like in car. So that's the hardware is always required. I can give normally example to my students. They are like body and soul. That software is the soul and hardware is the body. So they are important and necessary for each other. If you want to run software, you need a hardware. Then we have second attribute. It is called requirements. Software is always developed based on requirements of a customer. What is requirement? It's known as requirement, it is known as function, and agile we call it story. So what's requirement? A feature or function to be included in the new system is called requirement. We have types of requirement. We have functional requirements and we have non-functional requirements. Functional requirement, that software will perform functions. We develop software to perform some functions. For example, ATM system. The main functions of ATM system that you can withdraw money, you can transfer cash, you can check balance, and some ATM systems have deposit cash also. You can pay bill like electricity bill or mobile or telephone bill, landline bill. And similarly, in Microsoft Office, we have Word. The Word has menu bar, and in the menu bar, you can see home function, insert function, help function. For example, we have edit function, we have insert function. So there are different functions. So the main objective, you can do the documentation. Similarly, in PowerPoint, you can prepare your presentation, PowerPoint slides. You can have show, you have home, you have file menu, design menu, animation, review, view is there. And Similarly, Excel is there, you can do the calculations, and it also has the menu bar is there. So these are the functions of the Office, Word, PowerPoint, Excel. Similarly, for functions of ATM system, these are functional requirements. Then we talk about non-functional requirements, which are not related to functionality of the software, but they are as important for the success or failure of the software, like usability. Microsoft Windows usage is about almost 89 point something of the whole operating system market, and the other operating systems like Mac, Linux, Unix, Sun Solaris, Fedora, and so Linux, Red Hat is there, Fedora is there. So they are all almost 10%, and 90% market is captured by Windows. Microsoft's main strength is usability. Usability means easy to use. So all Microsoft software, all products, they have one common feature: they are highly user friendly, and people or end users are addicted of Microsoft software. So that is non-functional requirement. Then we talk about, for example, reliability. Reliability is not related to functionality of software. What is reliability? That software should have minimum bugs, and it must be stable. Like Linux or Unix are highly reliable. I normally gave example that Microsoft Windows is one of the most unreliable software because it may crash due to electricity jerk or due to some virus, and you have to format it and reinstall the Windows. So Linux is highly stable. Linux has minimum bugs. One of the main reason is that Linux is open, or Unix is open source. So whereas Windows is closed source and only Microsoft programmers can fix the bugs. In Linux community, open source community, whenever a bug is reported, thousands of programmers all over the world, they start trying to fix that bug, maintain that. We already covered in my previous videos. Start maintenance. And because of that, Linux bug is fixed as early as possible, and open source community helped to improve the Linux, and it is highly reliable. So these are about the requirements, the functional requirements and non-functional requirements. Then you have complexity, another attribute of software. What is complexity? Level of difficulty to solve a problem is called complexity. According to human nature, Allah has created human brain, and our brain is composed of cells, and we call them neurons. And there are millions of neurons are there. The cells are there. We as a human, when we perform something first time, it is complex for us. For example, like programming. For a fresh guy who is doing first time programming, especially using Notepad or WordPad without using framework, he found it extremely difficult, highly difficult, and highly complex. Like syntax, he has to follow, and he did not remember it, and he's doing first time. Like Java, you found it very difficult. So high difficulty is there, high complexity is there. Similarly, when you drive a car, you start learning driving car, especially manual car. You have to take care of the clutch, gear, brake, race, the combinations are there. So if you look down towards your feet where you have clutch, brake, race, your car will stop with a jerk and you will restart it, ignition, and then again you will have the same process. If you look front, you miss the steps. So it takes time to be comfortable to drive. And with the passage of time, your complexity in programming or in driving decreased, and you reach to medium or intermediate or average complexity. And then with the practice, as we say, we have a saying, practice makes a man perfect. With the practice in programming, syntax is memorized. You remember the syntax. You don't need to remember that system.out.print or import java.io.static, import java.applet and public static void main string arguments and so on. So you know you have to include the packages, then you have to include the main method, and then you have the class declaration, and then the naming, and the input, the variables, and then input, and then processing, and then output or inheritance, and so on. So programming from intermediate, it decreased to low, or driving decrease from high complexity to average and average to low. So at a certain level with the practice, you reach to that stage. Sometimes a call is received during driving and you start talking to that guy, the other guy, and meanwhile you take all turns, you control the car, you right, left, the direction, destination, you reach there to your destination, and suddenly you are surprised, oh, from your office or from wherever you have gone, you reached back to home or wherever you want to locate. So it's all automatic. You don't need to think about it because its perfection level is achieved and it's a simple complexity or low complexity is there. So that's the complexity. So we have software complexity also there, the project's complexity as a software company. When any company develop a software for the first time, I use the word project. I better like to define it. Project is a set of interrelated activities to accomplish or perform a task. That's a project. So we have types of projects based on complexity. We call them high complexity projects, average complexity projects, and low complexity projects. So all discussion I was doing because to reach to this stage, the types of project based on complexity. When you develop a project first time, you do it as a company, it's highly complex for you because scratch base or line 1 you started. You don't have any experience in that domain, in that area. Like BMW software for Netsol company was highly complex for the highly complex project for them. Because line 1, in 1990s they started that project. So they don't have any previous code, library or any components for there. So they have to do the planning, analysis, the architecture, and then code, the test. So it is highly complex project for them. Then after successful implementation of BMW, Mercedes-Benz also asked them to do that software, to develop that software for them. Now Mercedes-Benz has some different requirements as compared to BMW. So the Netsol company has some previous code and they have some new code, new requirements based on the Mercedes-Benz company. So that's average complex because they don't know what kind of logic, what kind of bugs they will face. So that's project transforms from high complexity to average complexity. And similarly, later on, Nissan company or Yamaha motorbike, heavy bikes are there, Yamaha bikes are there, Yamaha motorbike company. So they also asked them to develop that leasing software. They call it Lease Soft at that time in 1990s and early 2000 and so on. So the project has some previous code and some new requirements by the new customer, and they have to develop from line 1, and some code they can reuse from the previous project. So that's the average. From 1990s till 2019, they have 50 plus versions because they have NetSol company has implemented leasing software for BMW, Germany, then UK, then USA, then Australia, then Taiwan, then Korea, then India. And similarly for Mercedes-Benz, Germany, USA, UK, Australia, and Nissan and Yamaha. So 50 plus versions or 60 plus versions are there. Whenever new project comes, they just match which of the version is close to the previous requirements, and they just do customization and deliver to the customer. So it's a simple or low complexity. Another important attribute of software is the size. Software always has some size. We have software size in terms of lines. We calculate size in terms of lines or functions or objects. So lines also divide the software project type: small projects, medium projects, and large projects. If software size is less than equal 40K LOC, line of code, or source line of code, it is called small size project. So project normally evolves from small to medium and medium to large. If software size is up to 100,000, 100K, less than equal 100K, greater than 40K, it is called medium size project. And if it is greater than 100K, like in millions, like Windows or ERP system, it is called large size project. I use word ERP. I will discuss this ERP in another video. Just I will define it. It's called Enterprise Resource Planning System. So enterprise resource planning systems like SAP, Oracle, Microsoft Dynamics are there. So size also has 3 types of projects: small, medium, and large. Then you have schedule. Schedule is also another important attribute of software. We need time to code. And time also divides the types of project. We also call them small, medium, and large. A project is completed less than or equal 6 months, it will be called small size project. If it is completed less than or equal 1 year, it is called medium size project. If it is greater than 1 year, it will be called like 2 years, 3 years, or 10 years, or more than that, evolving software, it's called large size project. So software projects can be divided in terms of complexity, time, and size. And then you have cost. Software always have cost. It's not free. We develop software based on cost. Customer has to pay. So it's not free. We charge to the customer, and it has a cost. Normally, software company made a contract at the beginning. We also call it project charter. So charter is signed, contract is signed between software company and the customer. So we have different forms of payment. We have payment per line. Normally freelancers, they charge per line. There is a website, it's called Rent-A-Coder. So many of my students are working for this freelance company, Rent-A-Coder company, from early 2000, and this company pay them in terms of dollars per line. There is another way, we charge to the customer for the whole project, the full payment. The third type of payment, customer pay per release, per iteration or per release. So according to the size of release, customer will pay. Incremental development. These are the main attributes of software. Thank you very much. I hope so you enjoy this video. Assalamu alaikum.